Okay, welcome back, part two. So I'm skipping over to another worksheet, which, it doesn't matter what it is, but I'm going to try number three. So I'd like you to, again, even if you've done this previously and you think you did it successfully, maybe try to do it. See how quickly you can get the equivalent statement down, get the conversion factor set up, and run through your calculator and get the right answer. Let's see how quickly you can do it. Uh, okay, so here we go. So we've got on the left, we've got capital G. That's a gigameter, which means 1 billion meters. Over here we have kilometer, kilometer. That's 1,000 meters. So of course the gigameter is going to be much further up on the staircase. Let's go take a look. All right, let me clean this up a little bit. So you can see that giga is right here, top of the steps, and kilo is down here. And how many powers of 10 separate them? So giga is associated with 10 to the ninth. Kilo is 10 to the third. And I think you can just see from the exponents, right? 9, 3. So the difference between 9 and 3 is 6. 6 powers of 10. And you can actually do the steps 2, 3, 4, 5, 6. All right, so there is indeed 10 to the sixth power difference in magnitude between giga and kilo. So when we go back, we're going to start with giga. We're going to say 1 gigameter equals 10 to the sixth kilometers. All right, why 10 to the sixth? Because there's 6 powers of 10 that separate them. Okay, so here's the equivalent statement. So 1 gigameter equals 10 to the sixth kilometer. All right, and we'll use this to create a conversion factor. Okay, and also, well, let me work this, and then I'll show you something kind of cool. All right, so we start by writing what we have, which is 0.25 gigameters. So we have like a quarter of a gigameter. All right, and then multiply. Notice I'm not putting an equal sign here. These two things are not going to be equal. We're doing a multiplication operation. So the thing that we want at the end of our conversion is kilometer, right? So we want to put the kilometer part on top. That's 10 to the sixth kilometers over 1 gigameter. All right. And what that allows you to do is cancel the gigameters. And so then on your calculator, you type 0.25 times 1 times 10 to the sixth. Okay, so don't forget that on your calculator, 10 to the sixth is going to become 1 times 10 to the sixth. All right, and so if those of you who have EE buttons, so that's going to be 1 and then, sorry, 1 EE6. Simple as that. Okay, and when you do that, you should get 2.5 times 10 to the fifth kilometer. Okay, there you go. All right, what I was going to say about these equivalent statements, let me go down here and grab a little more space. Okay, so up here we said, let me use a simpler thing. Let's say we're trying to relate, let's take an everyday ordinary thing. 1 foot equals 12 inches. Okay, that's what we call an equivalent statement. And so if we have, say, if we measure your height and you are 68 inches tall, and we want to know, okay, well, how many feet is that? Let's convert that to feet. Well, you set up the conversion factor like so, and oops, did you see Dr. Hammer's mistake? I got the two things reversed. Let me back up, do that again. All right, so that's 1 foot over 12 inches. Okay, now inches cancel. All right, so let's freeze there. Let's hold on right there. Now, notice that we're saying that these two things are equivalent. If we, I should have just done this out. 68 divided by 12 is 5.67, and that's feet. Okay, so what we're saying is that 68 inches equals 5.67 feet. All right, and in order for those two things to be equal, this fraction that we're multiplying by has to equal 1, right? So if this whole conversion factor does not equal 1, then we can't say that these two things are equivalent. You know, different units, they're being measured in different units, but they are the same object. You know, they have the same length, right? We're just converting between two different units of measurement. And so the only way this thing is true is if this conversion factor is equal to 1. Now, this is what I'd like to try to convince you that that's actually the case. All right, let me grab my red pen. Okay, so again, if we start with 1 foot equals 12 inches, all right, now watch this. I can divide both sides by 12 inches, right? Okay, and when I do that, when I continue, then I'll just rewrite the left side. Okay, so that's 1 foot equals 12 inches. And the right side, I mean, you know, this is basically x over x, which is a big fat 1. So that's 1. And so this kind of proves that this conversion factor that I used up here is equivalent to 1. So I'm not doing anything illegal mathematically. You know, it's all above board and legal-like. Okay, let me clear this out a little bit here, and we'll do another problem. Okay, bear with me. Clean up. Let me push, actually. Hold on. Okay, sorry about that. Now let's go back. Let's take a look at number 8 here. All right, so now we're dealing with volumes. These are cubed units, so those are volumes. And so we need to relate a meter to a nanometer, right? So the equivalent statement would be 1 meter equals 10 to some power of nanometer. All right, so let's go over to the metric staircase. Here we go. Meter would correspond to the base unit, this guy, and then nano is way down here at the bottom. Nano, 10 to the minus 9, so that's 1 billionth of a meter. And so the difference, again, I think you can see 10 to the 0, which is 1, our base. The difference between 10 to the minus 9 and 10 to the 0 is 9 factors of 10. Okay, so so that's why I started with 1 meter on the left. It's 9 steps, 9 factors of 10, so 1 meter equals 10 to the 9th nanometers. But it is cubed, so let's do that. Cubed and cubed. All right, so now the equivalence, now that we convert it to volume, that's 10 to the 9 times 3, or 27, nanometers cubed. Okay, now we've got the working equivalent statement. So let's apply it. Okay, so they're giving us 9.4 times 10 to the second meters cubed. All right, and then conversion factor. What we want is nanometers cubed, so we're going to put the 10 to the 27th nanometers on the top and the 1 meters cubed on the bottom. And if we multiply all that out, you should get 9.4 times 10 to the 29th Oh, look, meters cancel, and we're left with nanometers cubed. Okay? All right. Again, don't forget, when you enter this number, 10 to the 27th, on your calculator, make sure it's 1 EE27, okay? Because that's 1 times 10 to the 27th in scientific notation. So your calculator expects that to be in scientific notation. All right. So let me try. Let's see. What kind of time do we have? Okay, we got time for one more. Again, let me pause this and clean up. Okay, now I've skipped back over to this other worksheet, and we're going to try this one, number 9. Let's try number 9 here. Okay, 55 miles an hour. You're driving the speed limit, and you want to know, well, how fast would that be in meters per second? All right, and here's a hint to help you relate a mile to a kilometer. Okay, so let's take this one step at a time. So there's two conversions that you got to do here. Notice that miles per hour, that's a compound unit. You know, there's a unit of length, right? Miles is a unit of length, and then you have units of time. So it's called a compound unit in that it's combining length, you know, elements of length and time. And this is a speed, right? Because it's, you know, telling you how many miles some object is traveling in 1 hour. So so we got two things going on here. We got to take miles and convert them to a different unit of length, the meter, which is much smaller than a mile, and then we need to convert hours from, you know, to seconds. All right, so a relatively long period of time to a relatively short period of time. Miles versus meters, that's kind of addressed right here in the hint. Hours and seconds, you know, I assume I'm making the assumption that you know how to convert between those two things, or you know the equivalence. All right, so first, right, 1 mile equals 1.609 kilometers. Okay. But that gets you part way, right? We went from mile up to kilometers, and now we need to get it to meters, right? But you know how to do that. 1 kilometer is 10 to the third meters. Okay, so you know that. And then finally, hours and seconds. How do we relate those? 1 hour equals 3,600 seconds, right? Because that's 60 seconds time, you know, in a minute times 60 minutes in an hour. So 60 times 60 is 3,600. All right, so let's put this all together. I'll start down here. So 55 miles per hour. All right, and now I'm going to apply the first conversion factor to get, I want to get miles into kilometers. So what I want is kilometers. That's 1.609 kilometers over 1 mile times. And then to get kilometers into meters, so that's 10 to the third meters over 1 kilometer. Okay, let me catch up here. So miles cancels miles, kilometers cancels kilometers. And now we have meters on top, but we still have these pesky hours, so we got to convert that. So I'm going to put 1 hour on top, 3,600 seconds on the bottom. All right, now hang on. Why did I put the hour on top? Well, because seconds needs to be in the denominator, right? So I've got to have my seconds in the denominator because we want meters per second. Also, the hours is in the denominator, and the only way to cancel hours is to put an hour in the numerator. So now these guys cancel, all right? And let's crank this through. That's 55 times 1.609 times 10 to the third, which is 1,000, divided by 3,600, and I get 24.6, basically. 24.6, and that's meters per second. Okay, all right. Okay, so guys, I hope that helped. I think I'm going to stop there. Hopefully between these two videos, you've been given some, good examples and support. So let's talk tomorrow and see where things stand. Okay, good luck.